Welcome back to the second part of the topic called improper integral. So today we are going to discuss the convergence of some standard improper integral. So let us have this example. Let us try to find the convergence of the integral integration a to infinity dx by x to the power n where a greater than 0. So here as you can see, this integral is an improper integral because it has in its limit, in upper limit is infinity. Now how to take care of this integral? So what will you do? Just like the theory, here as we have discussed in the theory, here we'll rewrite the integral in the form limit x goes to infinity a to capital X dx by x to the power n. And if we integrate it, we are going to get limit x goes to infinity x to the power minus n plus 1 by minus n plus 1 with the limit a to x. Next, put the limit. After putting the limit, we are going to get 1 by limit x goes to infinity 1 by n minus 1 whole into 1 by a to the power n minus 1 minus 1 by capital X to the power n minus 1. Now here two cases arises, basically three cases arises. If n is greater than 1 or n is less than 1, or the third case is n is equal to 1. Now when n is greater than 1, in this case what will happen? You see, as limit n goes to infinity, this 1 by x to the power n minus 1, sorry, this capital X to the power n minus 1, this will go to, since n is greater than 1, so this portion is basically greater than 0. Greater than 0 means 1 by x to the power n will be there, and as x goes to infinity, as x goes to infinity, 1 by x to the power n minus 1, that will go to 0. So ultimately we are going to get 1 by n minus 1 a to the power n minus 1. And if n is greater than, if n is less than 1, in that case what will happen? If n is less than 1, then this 1 by x to the power n minus 1, this n minus 1, that will be negative. If n minus 1 is negative, then x will come in the numerator. So x to the power n minus 1, or that is minus n plus 1, and that will give you. Now in the case when n is less than 1, basically n minus 1, that will be less than 0. In that case, this 1 by n minus 1 into x to the power n minus 1, this will be coming here 1 by n minus 1 into x to the power. In that case, the integral will not be convergent. And what will happen when n is equal to 1? If n is equal to 1, as you can see, the integral will be converted to a to infinity dx by x, which will be equal to, which we can write as limit x goes to infinity a to capital X dx by x, which will give you log x with a limit a to capital X, and the limiting value is going to be equal to infinity. Hence, we can conclude here that the improper integral is not convergent when n is less than or equal to 1, and it is convergent when n is greater than 1. Now, with the application of this particular result, we can quickly find the convergence of some type of integral. Like the first one, the improper integral 1 to infinity dx by root under x. You see, the power of x is 1 by 2. and since it is less than 1, therefore this integral will not be convergent. The second one, 2 to infinity dx by x to the power or dx by x cube, it is convergent as n is equal to 3, which is greater than 1. And if we consider this integral 1/3 to infinity dx by x, it is also not convergent as n is equal to 1. So this can be asked as MCQ, or the convergence can be asked as a 5 marks question. Moving to the next, so let us consider another type of integral. This integral is a to b dx by x minus a to the power n, where n is greater than 0. Now in this case, you can see at the lower limit of this integration, the integrand 1 by x minus a to the power n, it has point of infinite discontinuity. So here what will we do? Just like our previous one, here since at the lower limit, that means at the point x equal to a, we are having point of infinite discontinuity. So I'll take epsilon goes to 0 plus a plus epsilon to b dx by x minus a to the power n. On integration, we are going to get x minus a to the power minus n plus 1 divided by minus n plus 1 with the limit a plus epsilon to b. Now on the limit, we are going to get 1 by n minus 1, 1 by epsilon to the power n minus 1 minus 1 by b minus a to the power n minus 1. Now this is not a problem because this is a finite number, but here we are having problem. So if n is less than 1, as you can see, if n is less than 1, in that case epsilon will come in the numerator, and there as epsilon goes to 0, this portion is going to be equal to 0, and our limiting value of this limit will be minus 1 by n minus 1 into b minus a to the power n minus 1. And what will happen when n is greater than 1? If n is greater than 1, in that case epsilon will be in the denominator, and as epsilon goes to 0, 1 by epsilon to the power n minus 1, that will be going to infinity. So therefore, when n is greater than 1, we are not going to get a convergent integral. And what will happen when n is equal to 1? If n equal to 1, again we are going to get a to b x to the power n minus 1 to the x minus a to the power n, that will be written as a to b x minus a, and we are going to get the integral value of the integral to be log of x minus a with a plus epsilon to b, and here as you can see b minus a by epsilon that we are getting, and which will give us log infinity, which is equal to infinity. So therefore it is not convergent when n is greater than or equal to 1, and convergent when n is less than 1. Again, some quick example, we can see integration 2 to 3 dx by x minus 2 to the power 3 by 2. This is not convergent as n is greater than 1. 1 to 2 dx by root under x minus a, it is not convergent. It is convergent as n is equal to half, which is less than 1. And the improper integral minus 3 to plus 3 dx by x plus 1, it is also not convergent as the power of x minus 3, that is x minus a, is x plus 3, that is x minus a to the power n, that is equal to 1. So this way, quickly, without finding the convergence, we can quickly give the conclusion about the integral, about the improper integrals. Here is another improper integral. What is that? Here you see a to b dx by b minus x to the power n is greater than 0. In this integral, what is the problem? Problem is at the upper limit. And for that, what we will do? We will rewrite this integral in the form limit epsilon goes to 0 plus a to b minus epsilon dx by x. Normally we will be integrating here, And as you can see, whenever n is less than 1, the integral will be convergent, just like the previous one. And when n is greater than 1, the integral will not be convergent. That is, similarly, when n equal to 1, the integral will be converted to a to b dx by b minus x. Again, if you put the limit, we are going to get the value to be equal to infinity. Therefore, the improper integral is not convergent when n is greater than equal to 1 and convergent when n is less than 1. Okay? And similar way, we are having these three different types of improper integral, wherefrom we can quickly find whether they are convergent or not. Integration 1 to 2 dx by root under 2 minus x. It is convergent as n is equal to half in this case. Improper integral minus 1 to plus 1 dx by 1 minus x whole square. It is also not convergent as n is equal to 2, which is greater than 1, and 0 to 1 dx by 1 minus x. This is also not convergent as n is equal to 1. I hope it is clear to all. And with the help of these three results, and also with the properties that we have discussed, how to find the convergence of the integrals, convergence of the improper integrals, we can have this exercise. So this we are keeping as exercise. You can try it yourself. You can try at your own. So thank you, and in the next lecture we will be covering another part of improper integral, that is gamma function and beta function and related problem to gamma and beta function. So till then, thank you all.